Now today we will see MCU IDE 8051. It's a very good simulator in which we can run the program, we can simulate the program, we can simulate interface, a virtual hardware also. So it's a very good virtual platform to study the microcontroller and its application. So first step is go to the project and select new. Here we can give any name. Here we are giving EC 5th GGP and 8051. This is a project name. You can give any name for the project and you can select the destination. Here I am selecting desktop of the computer. Now here we have to select the MCU, that is microcontroller. Here I am selecting say 8051, enabling the external RAM, same way enabling the external code memory. Here both are enabled and press OK. So now it initializes and you are getting the integrated development environment. This is called IDE, integrated development environment. Here the middle window is the editor window and here we are getting untitled. So I am pressing file then new. So near the untitled, the second untitled 0 is there. So I am selecting untitled and pressing the cross, so it will remove from here, from this environment. Only untitled 0 is there and I am saving that untitled 0 by giving the new name as save as. So I am giving the name as, for example, this is a demo. So I am giving the file name as a demo test, and press OK. So it will give, do you want to add this file to the project? Project name is that EC. It will show here EC 5th GGP 8051 and the question the system asks that demo test.asm that will be added to this project. So I am giving yes. So it will automatically added into the project. This is a project window. I can add different files in this project window. And here this is the editor window of this particular project or this particular file, the first file of the project. Now I am writing a simple instruction. So for example, always we have to write certain instruction for the assembly language programming. So first thing is we have to write org 0000h, org 0000h. Then we have to write sjump start. Then the second thing is org 0040h. Then we have to write sjump so here we can write start and here, from here the program will start. So here I am writing move a comma 23h. Here I am writing move a comma has 23h. The meaning is that we can write in the comment section. If I write colon and then after whatever I write in that particular line, it is considered as a comment. So the meaning is A is loaded by 23 hexadecimal hex immediately. So here in microcontroller there is no instructions such as MVI in 8085. Here all instructions are just as a move. So here if I am writing move space a comma has 23h, the meaning is A is immediately loaded with 23 hexadecimal. If I am not writing H after has 23, the meaning is 23 decimal is loaded in A register. So I am writing this. Then after I am writing another instruction, say move B, move space B comma, move space B comma has 45, only 45, nothing H. Then after I am writing add A comma B. So A and B are added and the answer is available in A. Now the microcontroller is an embedded system, so all the program is running continuously. So we have to write here as jump here. Here there is an error. So if I put a label, then the error is removed. Now this is a simple way to write a program. It is in the continuous loop. The program is continuously in the loop. This is a small program. The file name is demotest.asm. The first instruction is not an instruction. It is not an executable instruction. It is only assembly directive. ORG means originate from 0000 address. SJump is an instruction that will jump to a label start. So where the label start is located? At address 0040. So why we are skipping the address from 0000 to 0040? Because from 0000 to 0040 in between there are locations of vector addresses of the interrupt. So we are skipping that vector addresses of the instruction or vector addresses of the interrupt and we are directly jump to 0040. This is a general practice of writing a microcontroller assembly language program. So this way we can write a small program in the editor window. Now the required thing is how to execute the program This is the first step, how to enter the program. Now the second step is how to execute the program, and third step is how to see the result. So how to execute the program, for that we have to go to the tools, because the file is already saved as a demo test.asm. Again, if you want to save, you can save it. So that will save as a demo test.asm, and then after go to tools and then compile. So if I compile, then you see this is the window which will see the result compiling. Then after creating this hex Intel hex file, then creating object file, that is a binary, then creating the assembler debug file, that is ADF, and creating the listing file, that will list file. So list file is very important, and it is a documented file, and it is exactly whatever the documentation of any program or any software you are writing, same way list file is created. So here we are getting one warning. Why we are getting one warning? Because we have not written end statement or end assembler directive. So if we want to remove the warning, we are writing the AND statement. So if I write AND, okay, so AND is assembler directive. After that nothing is there, or if anything is there, don't go. It's a command or assembler directive, that nothing that will be executed after AND. Just like a close bracket in the program in C. So here we are writing AND. Now if I again compile, then we are getting zero warning, zero error, zero warning. So this way we can write a program and we can execute the program. Now the third step is how to see the result. How I get that the program is executed perfectly, and how I get the correct result. So for that we have to go to the simulator. So simulator will simulate the program. So press simulator and start simulator. As we start the simulator, here we are getting the different windows. So here you can see this is a memory area, but this memory area is a internal memory area. Then this is input output port. Each and everything is expanded. So if I write input output port, then this way, then any messages like this, and then notes, for notes or something we can write a program and comment and everything. This is a calculator, and these are the different things. This is a simulator. Now here you see A and B. This is a value in hexadecimal, this is a value in decimal, this is a value in binary, this is a value in octal, and this is a value in character, that is ASCII. Now these are some SFRs. PSW, program status word, carry, auxiliary carry, F0, RS1, RS0, overflow flag, and parity. Here These are some SFR, TCON, timer control register, T mode, timer mode register. These are the bits, different bits, and the above thing is for the value of that particular register. This is a timer. Okay, the same way here interrupt enable and interrupt priority. Interrupt enable register, enable all, enable serial, enable timer 1, enable external interrupt 1, enable timer 0, enable external interrupt 0. Then priority of serial port priority bit of timer 1, priority bit of external interrupt 1, priority bit of timer 0, priority bit of external interrupt 0. Now these are the ports P0, P1, P2, P3. This is a value in binary. This is a value in hexadecimal. We know that when we press reset, all the port becomes FF, FF. A is 0, B is 0, PSW is 0. And these are the register R0, R1, R2, R3, R4, R5, R6, R7. So these registers are the registers of bank 0. Now PCON is a SFR having S mode. This is a 00. SCON, SM0, SM1, SM2, receive enable, then TB8, RB8, TI, RI interrupts. These are also 0. Clock is 12,000, that is kilohertz, means 12 megahertz. Then SBUF, serial buffer register, receive, serial buffer register, transmit, and value of SP is 07 at the time of reset. So this is the simulator, and this is also called the programming model of microcontroller. So any instruction will affect different registers, and the whole program will affect the whole environment of different registers, and we will see the effect of each and every instruction step by step programming, and at a time by the continuous or complete program. So here there are actually four buttons are there. If we put arrow on the first button, that is single step mode, that is step programming. The second button is step over. The third button is animate the program. If a virtual hardware is there, we can use this animate button, and this is for the full run program. Now if we use a step programming, mostly the step program or single step mode is used for debugging and learning and studying purpose. We always use single step mode. So first I press a single step mode, okay, because the program is already compiled, and hex file, binary file, every file that is created. So we are putting this single step mode programming. So whatever the instruction here, they are as jump start, so it will continue, it will coming here, and here A is loaded with 23. So when I execute the program, the 23 is here. So the value of A is 23. Now this instruction is executed. So value of A is 23 hexadecimal, and 35 is the decimal value, 16, then 35 is the decimal value, 16 multiplied by 2 plus 3, that means 23. 35 decimal and 23 is hexadecimal. Now this is a binary value, this is octal value, and this is a character. Now same way, if I step further, then value of B is 45, but here there is H is missing. So due to H is missing, 45 decimal, the equivalent to that is hexadecimal 2D, 16 multiplied by 2, that is 32, plus D, that is 13. So 32 plus 13 is 45. So this is 45 is decimal, and this is a binary equivalent. This is octal, and this dash is a character, ASCII. Okay. Now 2D plus 23, the answer we will get if we do by calculator here. So if we use a calculator, and in that calculator, if we use, say, 23 plus, then here 23, that is hexadecimal, hex, plus 2D, say we can put 23, that is hexadecimal, then plus 45 decimal, then value equal to, the answer is 80, but we require answer in hexadecimal, so the answer must be 50. So if we do this, the answer must be 50, and if I step further, then here we are getting A equal to 50. So A equal to 50 hexadecimal. So calculator is a manual, or if we are doing by addition, and here we are getting the same answer in the simulator. So this is the way of the first program, or this is the way to how to enter the program in the simulator in the editor window. After that, how to execute the program in integrated development environment of MCU IDE 8051, and how to see the result in the simulator. So this is the way. Now here there are so many different hardwares, or different applications are also available. So we are quickly see what are the different menu. So this is a file menu. We can save as, save all, save session, then edit menu, just like all these copy and select all and everything for editing, and switch command line, project, new, recent, open recent, and other simulator, start simulator, step over. So whatever the shortcut, that is also in the menu also. There are some virtual MCU facility also. So here SFR map, so we can have a look of all the SFR or special function register map. So we can use, or we can see the different SFR maps. Now simulator, then virtual hardware. Now this is a virtual MCU, then virtual hardware. In virtual hardware, there are so many different hardwares are available. So this is a LED panel. We can interface this LED panel with the 8051 or any port we can connect, and we can switch on and off by this. So this virtual hardware LED, then virtual 7-segment LED display, then another is virtual hardware different simulator run animation, another say LED matrix is also there, then multiplex 7-segment LED is also there, simple keyboard, matrix keyboard, LED LCD display, then temperature sensor, then tools we can use as a export, as a latex, export as XML, then other run, then utilities, hexadecimal to binary, binary to hex, then hex to decimal, binary, then hex editor, then 7-segment editor is very important. Here we can generate common cathode and common anode type of, say if I draw 0, then 0, and here if I put A as a port pin, say 0, port pin 1, 2, 3, 4, 5, 6, 7, P means DP. So here we are getting the common anode configuration code in hexadecimal, and this is binary, then common anode and common cathode code. So 3F and C0. If I put 8, then here 7F and 80. If I put 1, then here 0, 6 and F9. If I put 2, then here 5B and A4. So this way we can generate this 7-segment code, and very easily we can write in the program and in the lookup table. So these are the different ways. Here calculator facility is also there. Then continuous run, this is the application. Animation is also there, step program is also there. So there are different application or different facilities are there with the simulator. So by using MCU IDE 8051 simulator, we can learn microcontroller very easily. So in our manual microcontroller, each and every program you have to perform in this simulator, and you have to save the program with the directory which is created with the enrollment number of your enrollment number, and save the file as experiment number 1. If there are 4 programs in experiment number 1, then experiment number 1 underscore 1, experiment number 1 underscore 2, experiment number 1 underscore 3, experiment number 1 number underscore 4. So this way you have to save the program, and you have to save the assembly language file as well as save the session after running the program. So this way we can use the simulator and we can learn microcontroller very easily by interfacing the virtual hardware and the assembly language program.